All right, so this unit starts with the idea of an x-intercept. So on this little graph, it just says find the x-intercepts of each function. Before we even start, all of these are U-shaped graphs. What kind of equation gives us a U-shaped graph? Starts with a Q. Quadratic. So this is what we covered before. This is quadratics coming back into play. We have U-shaped graphs. What we want to find are the x-intercepts. Where's our x-axis? Horizontal line. So the x-intercepts would just be where the graph does what to that horizontal line? Intersects it, crosses it. So number one, how many times does it hit the x-axis? Twice. Where does it hit on the left side? Where does it hit on the right side? 2. So on the other 3, just write down where does it cross the x-axis. That's all the x-intercepts are, is where does this graph hit the x-axis. On number 2, where does it hit the x-axis? What about number 3? Number 4? Yeah, so you can see their answers are up there, but we're just writing down where it hit the x-axis. So if you have a graph, if you're trying to find the x-intercepts, it's literally just wherever it hits the x-axis. This concept is what we're going to be focusing on. So the next couple slides are kind of just like standards. So like math is based off of standards. These are more nationwide standards where it talks about like, oh, we're going to be working with equations. We're going to model. Models are graphs in math. There's mathematical practices, which again means like what are you doing to solve them? We are going to be graphing today, which is modeling. And then here's the big thing. We are going to solve quadratic equations by graphing. So a quadratic equation is a U-shaped graph. We know how to graph these. And we are going to end up solving them by graphing. The reason we are going to be able to solve them by graphing is we know how to graph these. So this slide here, we're going to add a couple things. We are going to be working with things in standard form. So whenever we graph a quadratic, we always have to start by finding our vertex. What formula gives us the x value of our vertex? Negative b over 2a. Once we find that x value of the vertex, how do we find the y that goes with it? Yeah, plug it in. So whenever we graph a quadratic, we find our vertex, we do negative b over 2a, we plug it in, and then we have to put on the side. So the normal side pattern, 1 squared is 1. What does 2 go with? 2 squared is 4. 3 squared is 9. So that is our normal side pattern of a quadratic. When we graph it, we put on our vertex and we go 1, 1, 2, 4, 3, 9. If we have a number in front, that a value, does it change the first part or the second part of our pattern? Second part. So all the things we already know about graphing, we are going to use to our advantage. Mainly, where's the vertex, and then putting on the sides. Is the next one like the big paragraph? Yeah, it is. Okay, so I'm going to read the first couple sentences of this paragraph to you because it's actually going to describe what we are trying to do. When I circle a word, you should also circle a word. So we are going to be solving quadratic equations by graphing. One method for finding the roots of a quadratic equation is to find the zeros of a related quadratic function. You can identify the solutions or roots of an equation by finding the x-intercepts of the graph. That's what we're going to be doing. We are going to be solving quadratics by graphing. And then big picture wise, you guys have been solving equations since probably middle school is when you first started solving equations for x. Technically, if you were to graph all of those equations, the solutions are always where it hits the x-axis. So all of the circled words, the roots, the zeros, the solutions, the x-intercepts, all means where the graph hits the x-axis. So when you are asked to solve something, you're technically finding where it hits the x-axis. There's lots of different ways you can solve things. Graphing is one method. If you're doing it graphically, you just look to see where it hits the x-axis. But all of those words, the roots, the zeros, the solutions, the x-intercepts, all just means where does this graph hit the x-axis. When we do it, we are going to be, so this one we're going to come back to. So this slide right here, we're going to come back to. When we do it, we are going to solve by graphing. So this quadratic right here, we know it's a quadratic because it's x squared. We want to solve this by graphing. When we graph, do we want like our variables and stuff on two sides, or do we just want it all together? All together. It is easiest to graph with a positive x squared. So do you see how our x squared is negative? So if I move it over to the other side, what will it turn into? Positive. My x's are already with it, so that's good. I also need to move the number over there. How do you move a positive 10? You subtract it. So what's 14 minus 10? 4. So step 1, set your equation equal to 0. You want everything on the same side. What this 0 technically represents is the x-intercept. Because if you think about your x-axis, it's not up, it's not down, it's right in the middle at 0. So the value of the x-axis is 0. That's why if we set it equal to 0, we'll find out where it hits it. When we graph this, we're just going to find our vertex like we normally do. So negative b over 2a. What is our negative b value? Negative 4. What's our a value? 2 times 1 is 2. What's negative 4 divided by 2? Negative 2. Once we have the x value of the vertex, how do you find the y value that goes with it? Plug it in. When you plug it in, make sure you use parentheses. When you plug it in, what do you get out? 0. So our vertex is at negative 2, 0. So our vertex is negative 2, 0. Now we have to put on the sides. Always look at the one that you set equal to 0. Do we have anything in front that's going to change that 1, 1, 2, 4, 3, 9? No. So I'm just going to go over 1 up 1, 2, 4, 3, 9. So you just graph it like normal. Nothing changed on that graphing other than we needed to move everything to the same side. The only difference for today is now we are being told to solve. Solving literally just means find your x-intercepts. That word means where does it hit the x-axis? Because the value of the x-axis is 0. So we're solving this equation, or the solving by graphing, just looking at the graph, where does it hit the x-axis? Negative 2. So the zeros of this, the roots of this, the solution to this, all mean the same thing. It means where does it hit the x-axis? So to solve something means to find its zeros. The value of the x-axis is 0. Means to find the roots of it, the solution. Those 3 words will be used interchangeably. It all just means where does it hit the x-axis. So all you're doing is graphing and then seeing where does it hit the x-axis. Now we are going to go back to this one. So how do you determine the number of solutions of a quadratic function? Except for we're just going to determine how many different ways can it happen. So if you are going to have a U-shaped graph hit the x-axis, how many times did this one hit the x-axis? 1 time. What point did it hit at? The vertex. So you can get one solution. One solution means the vertex hit the x-axis. Doesn't matter if it goes up or down. That graph is only going to hit the x-axis 1 time. What other number of solutions could we have? So we could get one solution. What else could we get? We could get two solutions. Because if you had something like this, it would hit the x-axis 2 times. There's one other type of solution. Alex says 0. 0 solutions is perfect. Now, I'm going to put the word real in parentheses, and that's going to come into play later. But you could get 0 real solutions because, like, if your graph was up, going up, it's never going to hit the x-axis. So when you're graphing, you're either going to get 2 answers, 1 answer, or you're going to get no answers because it's never going to hit the x-axis. So today we are solving by graphing, which just means we're going to graph it and then see where it hits the x-axis. Once you guys are done writing this, we're going to go ahead to this one. So same setup, except it's a different equation. So now it's x squared plus 7x equals 31x minus 144. Oh, because we skipped a slide, right? Put a slide next to put a star on that slide. We're going to come back to it at the end. So in between this one that we just did and the next one, there's something that like talks about a table. Put a star on that one because we're going to come back to it. So when whatever one mentions a table, we will come back to it. I moved it yesterday because I thought it made more sense to put it later on. So we are going to do the same thing solving by graphing. When you solve by graphing, you want it set equal to 0, and you want your x squared to be positive. So to start with, do you see how our x squared is positive? So I'm going to leave it there, and I'm going to move everything to the left side. So our x squared is going to stay. I'm going to move that 31x over. How do you move a positive 31x? What's 7 minus 31? How do you move a negative 144? So step 1, set it equal to 0. Step 2, graph it. So when you guys graph, first step is to find your vertex. What formula will give you your vertex? Negative b over 2a. What is the x value of this vertex? 12. Is that on your graph? So that's going to be one of the big differences between what we would normally give you and this curriculum. They might give you numbers that aren't always the greatest thing. However, is it that hard to add 2 more lines onto your graph? No. So things might not work out as perfectly as we're used to. To find your y, you plug it in. Just plug it into the one that you set equal to 0. What is the y value? 0. So I can't really go off of my graph here because it's the end of the page, but you guys can. So you'll have your dot over at 12, 0. Is anything changing our 1, 1, 2, 4, 3, 9? No. So you graph it like normal. It is a little bit off the graph, but you can just put 2 more tick marks. I can't graph on the right side because the page isn't there anymore. The solutions are where it hits the x-axis. Where does this graph hit the x-axis? What's the point of what? Because to find the x value of your vertex, you do negative b over 2a. To find the y part of that equation, you have to plug it in. Oh, I see what you're saying. I don't know how to write. That's what you guys were questioning, why I randomly put a 0 at the end. So, solution is just where it hits the x-axis, which is at 12. Okay, this is going to be an application type problem. And first we're going to talk about like how you guys would normally solve it. So this says use a quadratic equation. Quadratic just means we're going to have an x squared to find two real numbers with a sum of 24 and a product of 143. So I'm going to first show you guys what you normally like would have done, because you guys have solved these before in Algebra 1. The sum of two numbers, what operation means sum? Add. So you guys would write like x plus y equals 24. Product, what operation means product? Multiply, and then you would do like x times y equals 143. And then you guys would either do like substitution or elimination to solve this system of equations. However, we have two variables. When we do our quadratics, do we have two variables or just one? Just one. So we are going to have to set this up a little bit differently. You guys will have a homework problem like this tomorrow, so make sure you guys write this one down. This is kind of tricky, but it's the idea of like building up a quadratic in a more abstract sense. And the abstract sense I'm going to give you is if I told you the sum of two numbers was 10. The sum of two numbers is 10. That means if I add them, they equal 10. If I told you the first number was 3, 3 plus what number would make that be a 10? 7, right? Like 3 plus 7 would equal 10. So if we think about it in the other way, how did you guys get that 7? You subtracted it, right? If you want to know what number that would be, it would just be like, oh, it's 10 minus 3. That would be the other number, because adding and subtracting are opposites of each other. So you can use them to help you figure it out. So what we're going to start with is the product is 143. So x times some number has to equal 143. And then here's where it's kind of a leap. Like today I'm going to show you this leap. Tomorrow you're going to try it on your own. Monday you're going to maybe try it again. But we now need to figure out the sum of two numbers is 24. So x plus some number has to equal 24. So both of these parentheses are the same number, right? Like x times something has to be 143. X plus that same thing needs to be 24. So I'm not using variable, I'm just leaving it blank. But if I wanted to get this number, whatever it is by itself, how would that x move over to the other side? What undoes a positive x? Subtract it. So I'm going to say that other number is whatever 24 minus my first number is. Just like over here, 3 plus 7 is 10. That 7 comes from 10 minus 3. So it's putting both of the rules together in one step. This will then be a quadratic, because when I multiply this out, x times 24 is 24x. What's x times x? X squared. So there's where our x squared comes into play. This is now a quadratic. So this is written in one variable instead of two, so we can solve it by graphing. Once you have this line, it's the exact same thing. To solve this, we need to get everything on the same side. This x squared is negative. Do we want it negative? No. So I'm going to move it over to the other side because it'll be positive. When this 24x moves over, will it be positive or negative? Negative. What about that 143? Still positive. So that is the quadratic we want to graph. When we graph this quadratic, we find the vertex first. What formula gives us our vertex? Negative b over 2a. What is the x value of our vertex? 12. How do you find the y value that goes with it? Plug it in. When you plug this one in, it will not be 0. I have 1, -1. Do we have an agree with -1? Okay. So our vertex is at 12, -1. Is that on your graph? No, again, they might not give you perfect numbers all the time, but we can extend our graph 12, -1. Now we have to put on our sides. Is anything affecting this 1, 1, 2, 4, 3, 9? No. So for my vertex, I'm going to go over 1, up 1, 2, 4. We are trying to solve this graph. So once you have your graph, to solve it, you just look to see where it hits the x-axis. Where does this graph hit the x-axis? Where is it on the left side? Where is it on the right side? 13. Now here's the part. We needed two numbers that when we added them together equal 24. What's 11 plus 13? 24. We needed two numbers that when we multiplied them was 143. What's 11 times 13? 143. So these numbers fit that bill. So the idea of a quadratic solution is always going to be where it hits the x-axis. Something to ponder. You guys do not have this in your notes. But even though 9 and 15 are not the solutions, even though the answer, like when you add them together, is 24. Why can't 9 and 15 be our solutions? Because when you add them together, that is 24. Yeah, they don't multiply to 143. So it has to fit both parameters. Okay, go back to that one that we skipped. So it should be right above it, right? Okay, you guys do not have these tables on here. If you want to add them, you can. You don't have to. I just want to point out, like, what does it mean if you're trying to find the solution from a table? Your solution is always where it hits the x-axis. So we are still looking for our x-intercepts. What is the value of the x-axis? So your x-axis is right in the middle. Does it go up, down, or is it literally at 0? It's at 0. So your x-intercepts just mean y equals 0. So sometimes, like, if you're looking at this table, where would it hit the x-axis? -2. We can literally, it equals 0. So if your y value is 0, if you were to graph this, literally that is on the x-axis. So sometimes when you look at a table, you can just look at a table and say, like, this is my answer. This one is not in there, you guys. This is the one that we skipped. The tables aren't in there. If you want to write them down, you can, but you don't have to. The one next to it is kind of the tricky thing. And this is getting at, it's called the intermediate value theorem. When I look at this, none of these equal 0. However, pattern-wise, if I look at my first two values, if I'm at -3 and then I go to +3, what number does it have to pass through to go from -3 to +3? Does it have to equal 0 at some point if it's going to go negative to +3? So even though we don't know exactly what it is, it's somewhere between x equaling -2 and -1. Because again, if you're going to go negative to positive, it has to go through 0. What other two numbers would you have to pass through 0 to get there? 5. Yeah, 4 and 5. The same idea, if you're at +3 and you're going to go to -3, do you also have to pass through 0 at some point? Yes. So we don't know exactly what decimal it is, but you can get approximate answers. We're going to use other methods. Those other methods will cover these, what if they're not exactly at a nice number. So just know, like, from a table, there's not really any work to be shown. You will practice these tomorrow. We are going to do one more example. This is the last one we're going to do. So we want to graph this. Step 1, is this set equal to 0? This one should be in your notes. Is this quadratic set equal to 0? Yes. So we can just jump right into graphing it. (-b/2a). What is our (-b)? -3. What's our a value? -1. As a decimal, what's -3 divided by -2? 1.5. So that is the x value of our vertex. How do you find the y that goes with it? Plug it in. When you plug it in, That negative is in front, so make sure you put it in front. This one will be another decimal. .25. We did a couple graphing like these in our other unit. So our vertex is at 1.5, 9.25. So it's not on a corner, it's just kind of floating in the bottom portion of that box in the middle. Now our side pattern. With that negative in front, are we going to count up or count down? Down. And when you count down, you just do your best to keep that spacing. So I'm going to go over 1, down 1, but I'm still like a quarter above that line. Then you go over 2, down 4, over 3, down 9. So your graph, if you do not have a vertex that's on a corner, you just keep that spacing when you count out your pattern. Our goal is to find out where this graph would hit the x-axis. How many times does it hit the x-axis? 2 times. We can see it's 2 times. But is it at nice numbers? No. So for right now, we are just going to estimate these. So whenever you're asked to estimate them, when you find your zeros, your solutions, your roots, you just state what 2 numbers they're in between. So the one on the left side, what 2 numbers is that going to be between? Yeah. So we're between -2 and -1. On the right side, what 2 numbers is that between? 4 and 5. So it's some decimal. We'll learn other methods to actually get those decimals. Today, we're just gonna kind of have to be okay with they don't need to pass through perfectly. You can be in between.